Consider what happens inside the brain after a single night of disrupted sleep, not how you feel, but how you calculate risk. Research from multiple independent laboratories has established something that should concern any investor. Sleep deprivation does not simply slow your thinking. It fundamentally alters how your brain weighs potential gains against potential losses. Evidence suggests this neurological shift shares measurable features with states of clinically documented impaired judgment. Most professionals making consequential financial decisions today are routinely operating on this neurological profile. Camera change. The connection between sleep and financial decision-making sits at the intersection of cognitive neuroscience and behavioral economics, two fields that have only recently begun to speak to each other in a coherent, integrated way. What they have collectively found is not about feeling groggy or making small arithmetic errors. It is about a systematic, measurable shift in how the brain evaluates uncertainty, probability, and risk. Not a quantitative reduction in raw intelligence. A qualitative shift in the kind of judgments being made. This is not a wellness conversation. This is a performance conversation. And the evidence suggests that most high-functioning professionals have fundamentally miscalibrated their understanding of sleep's relationship to financial cognition. Over the next 15 minutes, we will examine the specific neurological mechanisms involved. We will look at what the peer-reviewed research actually demonstrates, naming researchers and what their studies specifically found, rather than invoking vague scientific authority. We will examine why the dominant culture around productivity and sleep has the relationship precisely backwards. And we will lay out a practical, evidence-grounded framework. The research base here has been replicated across multiple independent laboratories, using different methodologies and different populations. By the end of this video, you will understand why the decision about how many hours to sleep tonight may be among the most consequential financial decisions you make today. Graphic, brain anatomy diagram highlighting prefrontal cortex and reward circuitry, labeled separately. Begin with the architecture. Financial decision-making in the human brain is not a single unified process. It involves a continuous, dynamic negotiation between two broad systems. The first is the brain's reward circuitry, a network of interconnected structures that evaluates potential gains and generates motivational drive toward them. When an investment opportunity appears compelling, when a trade seems obvious, when a potential gain pulls at your attention, this system is active. The second is the prefrontal cortex, the executive region immediately behind the forehead, responsible for inhibitory control, long-term planning, and the modulation of impulses generated by the reward system. This is the region that applies scrutiny. That asks, what is the actual probability here? What does the downside look like? Is the short-term opportunity worth the long-term exposure? Neuroscience, brain MRI scan neural activity visualization, neuroscience laboratory equipment. In a well-rested brain, these systems maintain a functional balance. The reward circuitry generates interest. The prefrontal cortex applies judgment. Remove adequate sleep from that equation. Venkatraman and colleagues, in research published in 2011, found that sleep-deprived individuals showed altered activity in the brain's reward system, activity measurably associated with increased risk-taking in financial tasks. This was not a subjective self-report. It was an observable, documented change in neurofunction tied directly to financial behavior. Camera change. Separately, Doran and colleagues, in 2001, documented that sleep deprivation affects the functioning of the prefrontal cortex, with associated impairment in attention, memory, and the executive functions concentrated in this region. The system responsible for applying brakes to impulsive choices becomes measurably less effective. Consider the combination carefully. A reward system more reactive to potential gains. An inhibitory system less capable of applying scrutiny to those gains. Gujar and colleagues found that this combination increases financial risk-taking in ways that parallel the effects of alcohol intoxication on the brain's reward system. That comparison is not rhetorical. It is a documented parallel and mechanism. We accept readily that alcohol impairs financial judgment. The neuroscience here suggests sleep deprivation acts through related pathways, yet we do not treat them with comparable seriousness. Unexpected stat. Research indicates that chronically sleep-restricted individuals tend to underestimate their own degree of cognitive impairment. The subjective sense of functioning normally diverges substantially from objective performance measurement. This is the crucial implication. If you cannot accurately perceive the impairment, you cannot compensate for it. The investor who believes they are operating at full analytical capacity, while their prefrontal inhibitory control is measurably compromised, is in a uniquely vulnerable position. Harrison and Horn, publishing in 2000, documented that sleep deprivation impairs attention and executive functions, the cognitive substrate that underlies careful financial analysis. The deficit is not in raw processing speed. It is in the application of executive judgment to complex, uncertain situations. Pacing, pause after uniquely vulnerable position. Allow the implication to settle fully before the next transition. Camera change. If this channel's approach, anchoring every claim in actual peer-reviewed research rather than motivational assertion, is useful to you, subscribing ensures you see the next analysis. Now, what the study specifically found in detail. Graphic, research timeline, 2000 through 2011, for key papers and authors. The research based on sleep and financial cognition has built incrementally across more than a decade, from multiple independent groups. Let us examine what the key studies actually found, and be precise about both what they demonstrated and what they did not. Harrison and Horn, in 2000, provided foundational evidence that sleep deprivation impairs attention and executive functions in ways that reduce performance on tasks requiring decision-making. This established the baseline. The impairment is not simply about slowing down. It is about the quality of the cognitive machinery applied to complex choices under uncertainty. B-roll series, scientists reviewing published research data, peer-reviewed journal, academic laboratory. Doran and colleagues, in 2001, added anatomical specificity, documenting that sleep deprivation affects the functioning of the prefrontal cortex, with impairment in attention, memory, and the executive functions concentrated in this region. The prefrontal cortex is not a peripheral system. It is the region most distinctively engaged in the kind of forward-thinking, consequence-weighing analysis that separates considered financial decisions from reactive ones. Camera change. McKenna and colleagues, in 2007, examined the behavioral output of these neurological changes, finding that well-rested individuals tend toward greater risk aversion and caution in their financial decisions compared to sleep-deprived individuals. Their research also indicated evidence of a bias in sleep-deprived subjects toward short-term gains, even at potential cost to longer-term financial stability. Sit with that finding. A measurable bias toward short-term gains at the expense of long-term stability. This maps closely onto the behavioral finance literature on myopic loss aversion, the tendency to weight immediate outcomes disproportionately relative to distant ones. It is one of the most well-documented patterns in poor investment behavior, chasing short-term performance, reacting to daily market noise, abandoning fundamentally sound positions during periods of short-term volatility. Unexpected stat. The short-term bias pattern documented in sleep research aligns with what behavioral economists describe as present bias, a systematic overweighting of immediate outcomes that appears measurably worse under conditions of sleep restriction. Venkatraman and colleagues brought it together in 2011, specifically examining financial risk-taking in a task requiring careful weighing of gains and losses. Sleep-deprived participants showed altered reward system activity and increased risk-taking. Critically, their findings indicated that this effect was more pronounced in situations requiring careful consideration of both potential gains and significant potential losses, precisely the high-stakes decisions where accuracy matters most. B-roll series, investor analyzing financial charts, market data screens, high-stakes decision moment. Consider what that means in practice. The impairment is not distributed evenly across decisions. It amplifies in exactly the situations where the stakes are highest, where careful analysis is most consequential. Not in routine, low-consequence choices. In the decisions that carry the greatest financial weight. Pacing, pause here. This is the pivotal finding. Allow a full beat before moving forward. Camera change. We have established the neurological mechanism and what the research documents. What remains is the part with direct practical consequence. Why conventional wisdom around sleep and performance has this relationship precisely backwards, and what a defensible framework actually looks like. Graphic: 6 hours versus 8 hours. Common productivity culture assumptions. The prevailing culture in professional and entrepreneurial environments treats sleep restriction as a productivity trade-off. Sleep less, work more, gain hours. The logic appears straightforward. Time is finite, sleep consumes it. Therefore, reducing sleep increases available productive hours. This calculation contains a critical flaw. It treats all cognitive hours as equivalent. It assumes that the analytical output of hour 9 of wakefulness is comparable to hour 7. The Neuroscience says otherwise. Bureau CUE, busy office at night, professionals working late, sleep-deprived entrepreneur. The specific impairments documented across the research: reduced prefrontal inhibitory control, heightened reward system reactivity, bias toward short-term gains, impaired executive function, do not affect all cognitive tasks uniformly. Routine, procedural tasks are relatively resilient. Complex, high-stakes decisions under uncertainty are disproportionately affected. Camera change. This means the professional who sleeps 6 hours to gain 2 working hours has made an implicit exchange. They have traded 2 additional hours of lower cognitive demand work for impaired functioning throughout the remaining hours, impaired most acutely for exactly the kind of complex financial analysis that generates the most value and carries the most risk. The conventional wisdom compounds this error through the normalization of chronic restriction. 6 hours becomes the baseline. The subjective sense of impairment fades as adaptation occurs. Research indicates, however, that objective performance continues to decline under chronic restriction even as the subjective sense of impairment plateaus. The individual believes they have adapted. The cognitive evidence suggests otherwise. Unexpected stat: evidence in the sleep science literature indicates that after multiple nights of restriction, individuals progressively lose the capacity to accurately assess their own level of impairment. Confidence in judgment and quality of judgment diverge. There is also a specific misconception about recovery. The intuition that a single extended night of sleep fully restores the cognitive deficits accumulated over a week of restriction is not well supported by the research. Recovery from chronic sleep restriction appears to be a more gradual process than most professionals assume. The conventional wisdom, in short, optimizes for visible hours while ignoring the quality of the cognitive architecture operating within those hours. For decisions involving financial risk, where the documented impairments are most pronounced, this is a systematically poor trade. Graphic 3-part framework: protect, calibrate, adjust. The research suggests a practical framework organized around 3 principles. The first is protection of the decision window. Evidence indicates that sleep deprivation's most significant effects concentrate in complex, high-stakes decisions under uncertainty, precisely the decisions with the greatest financial consequence. The practical implication: make high-consequence financial decisions in a protected cognitive window. Not in a state of acute sleep deprivation. Not after extended wakefulness. This is not a soft recommendation about feeling your best. It is an attempt to operate the prefrontal cortex when it is measurably functional. B-roll CUE, structured morning routine, calm focused workspace, deliberate planning environment. The second principle is calibration of self-assessment. Research indicates that sleep-deprived individuals tend to underestimate the degree of their own impairment. The confidence you feel in a financial judgment is not a reliable indicator of that judgment's quality when sleep-deprived. Building in external checks, a second opinion, a structured review period, a written analysis completed when well-rested, compensates for the unreliable internal calibration that the neuroscience documents. Camera change. The third principle is recognition of the short-term bias. Evidence from McKenna and colleagues suggests that sleep-deprived individuals exhibit a measurable bias toward short-term gains at potential cost to long-term stability. Recognizing this bias as a neurologically driven artifact, rather than a sound analytical conclusion, creates the possibility of a corrective adjustment. When a decision feels urgently attractive in a state of sleep restriction, the research suggests that urgency itself may be a signal of compromised judgment rather than genuine opportunity. Pacing. Each of these three principles should land as a distinct, separate point. Allow space between them. None of these principles require dramatic lifestyle change to implement. They require a reframing, sleep not as a recovery cost but as a cognitive input. Specifically, the input that determines the quality of the prefrontal inhibitory control brought to bear on financial decisions. The science does not tell you precisely when to go to sleep. It documents clearly what the evidence shows happens to your financial brain when you do not. Camera change. The research from Venkatraman, Harrison and Horn, Doran, Bujar, and McKenna converges on a consistent picture: impaired prefrontal inhibition, heightened reward sensitivity, bias toward short-term gains, and amplified risk-taking concentrated in exactly the high-stakes situations where accuracy is most consequential. The dominant professional culture treats sleep restriction as a productivity strategy. The neuroscience treats it as a form of measurable cognitive impairment with documented financial consequences. These are not compatible positions, and the evidence is clear about which one the research supports. Graphic and screen overlay. If the evidence-grounded approach this channel takes to financial neuroscience is useful to you, subscribe. Every analysis here is anchored in peer-reviewed research, named researchers, and documented findings, not motivational framing. Point to end screen card position. The next video examines how chronic stress reshapes the brain's financial decision-making architecture, and what the evidence actually shows about whether those changes are reversible. It is right here. Pacing. Maintain full energy through the final second.